What specific problem does your research address regarding prompt formats in LLMs, particularly in relation to existing evaluation standards?
Our research addresses the significant issue of how prompt format variations impact the performance of LLMs, specifically highlighting that existing evaluation standards often overlook this factor. We found that minor changes in prompt structure can lead to substantial performance discrepancies across different GPT models, which contradicts the assumption that prompt formats have a stable effect. Our study reveals that current evaluation approaches typically utilize fixed templates, potentially resulting in misleading conclusions about model efficacy. By investigating the effects of broader prompt format changes, such as plain text, Markdown, YAML, and JSON, on the performance of GPT models, we aim to provide a more comprehensive understanding of how these formats influence model outputs. This research underscores the need for more nuanced evaluation standards that account for the sensitivity of LLMs to prompt formatting.
How does the proposed method or algorithm work? Illustrate the process step by step, detailing any novel components involved in your approach.
The proposed method evaluates the impact of different prompt formats on the performance of GPT models through a systematic experimental setup. First, we design prompts using 4 distinct formats: plain text, Markdown, YAML, and JSON, ensuring that the content remains consistent while only varying the structure and syntax. Next, we assess model performance across various tasks and datasets, employing task-specific scalar scoring functions to measure the effectiveness of each prompt format. We then conduct a one-sided matched pair t-test to determine the statistical significance of performance differences between the best and worst performing formats for each model, revealing that prompt format significantly influences model efficacy. Finally, we analyze the consistency of responses across different templates and calculate the intersection over union (IOU) to assess the transferability of top-performing templates between models, providing insights into optimal prompt design strategies.
Can you provide a specific example demonstrating how a change in prompt format impacts the performance of one of the GPT models on a chosen benchmark?
In our study, we observed a significant performance impact when changing the prompt format for the GPT-4 model on the human-eval benchmark. Specifically, when the prompt format was switched from JSON to plain text, the GPT-4 model exhibited an impressive performance boost of over 300%. This dramatic improvement highlights the model's sensitivity to prompt format changes, suggesting that the choice of format can drastically influence the output quality. Additionally, similar results were noted with the GPT-35 Turbo models, which showed a 200% improvement when transitioning from Markdown to plain text in the fine dataset. These examples underscore the critical importance of prompt format in optimizing model performance across various tasks.
What are the practical benefits of your findings in terms of improving LLM performance and guiding practitioners in prompt engineering?
The practical benefits of our findings lie in the demonstrated sensitivity of GPT models to prompt format variations, which can lead to significant performance improvements. For instance, we observed that switching from Markdown to plain text resulted in a dramatic 200% performance boost for GPT-35 Turbo on the fine dataset, and over 300% for GPT-4 when changing from JSON to plain text. This highlights the importance of prompt engineering, as practitioners can optimize model outputs by carefully selecting prompt formats. Additionally, our research indicates that larger models like GPT-4 exhibit better consistency across different prompts, suggesting that practitioners should consider model size when designing prompts. Overall, our study provides actionable insights into effective prompt formats, enabling practitioners to enhance LLM performance across various tasks.
How was your method validated or tested? Describe the datasets used, the experimental design, and the metrics employed to measure the effectiveness of different prompt formats.
Our method was validated through a comprehensive experimental design that involved testing various prompt formats across multiple datasets. We categorized our datasets into 3 main groups: natural language to natural language, NL to NL, natural language to code, NL to code, and code to code, code to code, utilizing benchmarks such as MMLU, NER Finance, HumanEval, and CODEXGLUE. To measure the effectiveness of different prompt formats, we employed task-specific scalar scoring functions and conducted a one-sided matched pair t-test to assess the statistical significance of performance differences between various prompt templates. Additionally, we calculated consistency metrics to evaluate the uniformity of model responses across different formats, with a focus on the proportion of identical outputs generated by the models. This rigorous approach allowed us to draw meaningful conclusions about the sensitivity and consistency of GPT models in response to prompt format variations.
What were the key results of your study, particularly in terms of performance variation across different prompt formats and their impact on model responses?
The key results of our study indicate that the performance of GPT models varies significantly with different prompt formats, as evidenced by our statistical analysis. We found that the differences in model performance due to prompt format changes were statistically significant, with p-values mostly below 0.01. For instance, switching prompts from Markdown to plain text resulted in a dramatic 200% improvement for the GPT-35 Turbo models on the fine dataset, while the GPT-4 model exhibited over a 300% performance boost when changing from JSON to plain text on the HumanEval benchmark. Additionally, our consistency analysis revealed that larger models like GPT-4 demonstrated better reliability across different prompts, achieving consistency scores above 0.5 compared to the lower scores of the GPT-3/5 Turbo series. Overall, our findings highlight that prompt format choices can lead to substantial performance variations, emphasizing the need for careful prompt design in leveraging LLMs effectively.